In this video, we're going to evaluate two integrals involving the natural log function using integration by parts. And we have the formula here in red. The integral of u dv will equal to the product of u and v minus the integral of v du. And this is your general formula. There are some abbreviated forms that you can use. DI method, tabular method. We're going to use the general formula here because this is not too bad here. So we're going to look at the first one here. So for this particular formula then, you have to identify the function u in the integral here. And that's what you're going to differentiate. Define du. And then you're going to want to find or identify a function dv. And that's what you're going to integrate so you can get this product u times v. So we're going to find the u. So we look at the integral here. The integrand is ln of x. And we only have one function there. But remember, you can always multiply by 1. It doesn't change it. So if I let u equal to ln of x, then du, the derivative, would equal to, okay, derivative of ln of x, that's 1 over, whatever this expression is, it's x, so it's 1 over x. And then it's times the derivative of x, which is the 1. So it's 1 over what this is here, x, and then it's the derivative of x. And then this will be dx. And then the dv has to be something that you can integrate. Well, the only thing that's left here is 1. 1 times ln of x is ln of x. So let's make this equal to a 1, or dx here. And we integrate the left side with respect to v here. Get v. Integral with respect to x over here would be x. And there you have it. So then this is equal to, and then this is your formula now. U will be something you differentiate. So you have to pick these appropriately so they come out nice. And dv has to be something that you can integrate. You can always integrate 1 with respect to x. That's why I picked the 1 over here. So then, according to the formula, the first part of the answer is the product of u and v. Well, u we picked to be ln of x, so this will be ln of x. And v we got x. So that's the first part of the answer, that product right there. U, ln of x, and v is x. And then what we have now it's a minus the integral of v, so we come back over here to v, that's x. And then what else? Du. Well, du is right here. So that's going to be 1 over x dx. So then we can go through this and say, okay, this is going to be x, ln of x. So notice this cancels out, the x and the x cancel out, so that just leaves me 1. The integral of 1 dx. Well, the integral of 1 dx is just x. And then you have your constant of integration. Now it turns out that to work out number 2 here, you need this integral here. You need this integral. So now we know that the integral of ln of x dx is this. Now we're going to do the second one then. And we're going to use, eventually we're going to use this, the result of problem 1. So for this one here, in the same way, I'm going to select u to equal to ln of x quantity squared. This does not equal to this. The way I had it there, it does equal. If I put the 2 here, the way I had it, they are the same thing. But if you have the 2 here on the x, those are the same thing. properties of logs allows you to bring this to the front. So I can rewrite this as 2 natural log of x. So if that were legal, I already have the answer to this. We got it over here. Just multiplied by 2 and that's it. But like I said, those are not the same thing. I put it here, it is. So let's do this then. Got u equal to ln of x squared. So here, take the derivative of this, the 2 comes out in front, that'll just be 2. Then I subtract 1 from the 2. And that just needs to be ln of x to the first power. And I can just leave it like that. And then you have to apply the chain rule to this. The derivative of ln of x is 1 over x, so I'm just going to put the x here. And like number 1, the dv, there's nothing left in the integrand other than 1. 1 times anything will give me that same expression back. So the dv is going to equal to 1 dx. So we'll integrate here, so it'll be v and then x. So now let's get down to this one then. This is equal to, and that's why I included this problem here, number 1, because I knew we would have to use it to work number 2. So the answer to this, and the first part of the answer should be u times v. So these two values get multiplied. I'll put the x out in front, and then I have parentheses ln of x quantity squared. Then it's minus the integral of v, right here, v du. So there's your du right here. So I'll put it in parentheses here. This will be 2 ln of x over x. And this one, of course, I need my dx. So I need a dx right here. So I got 2 ln of x over x dx. And of course I know what the v is. I have to put v here, but I know that v from this step here is x. Put an x right here, and the x and this x cancel. So let me rewrite this. Let me go up here so you can see everything here. So this is equal to the x here, ln of x quantity squared, and then I have a minus, and again the x is cancelled out, and the 2 right here, that's constant. You could always bring that outside the integral, so I'm going to put the 2 out here in front. The integral of, and what do we have? This cancels out, so what I have here is ln of x dx. So now all we have to do then is find the integral of ln of x dx. Well, we did that over here in part 1, problem 1. So we'll just do this then. This is equal to, just write everything down again, ln of x quantity squared. And then the answer to this right here, I have it right there, x ln of x minus x plus c. So I'll just multiply it by a negative 2. So that'll give me then minus 2. Over here's multiplying this answer here, x ln of x minus x by 2, minus 2. So that then gives me a minus 2. That's ln of x, and of course I got the x also here. And then I got a minus x here, then that's multiplied by a negative 2, so it'd be a plus 2 x. And then of course the constant gets multiplied by 2 also, but that's just another constant. I'm just going to put c. So this will be plus c. So using the result from problem 1, this is what we get for the integral of problem 2. It's x ln of x quantity squared minus 2x ln of x plus 2x plus c. Thanks for watching. We'll see you next time.